Solve 2 to the power x plus 4 to the power x equals to 8 to the power x. So here, first we will divide each terms by 2 to the power x, since 2 to the power x is greater than 0. As you can see, 2 to the power x over 2 to the power x simplifies to 1. Next, we can write 4 to the power x over 2 to the power x as 4 by 2 whole to the power x, and similarly on the right hand side. Inside the bracket, as you can see, 4 over 2 is 2 and 8 over 2 is 4. So we'll have 1 plus 2 to the power x equals to 4 to the power x. Now 4 can be written as 2 square. So we'll have 2 square whole to the power x. And since power and power gets multiplied and multiplication is commutative, so we can write 2 to the power x whole square. We will assume 2 to the power x as y. Our equation simplifies to 1 plus y equals to y square. Let me write all the terms on the left hand side. Then it will be y square minus y minus 1 equals to 0. Now this is a quadratic equation in y, which is in general form, and if I compare the coefficient of y square, y and constant terms, then I will have a equals to 1, b equals to minus 1 and c equals to minus 1. For this we have our quadratic formula like this, and in next step we will put all the values, and if you simplify all this, it will be y equals 1 plus minus root over 1 plus 4 over 2, and this further simplifies to y equals to 1 plus minus root over 5 over 2. Now since 2 to the power x was greater than 0, that is y is greater than 0, so we cannot have negative value here. Y will be equal to 1 plus root over 5 over 2, and we have assumed 2 to the power x as y. Now if I compare these two equations, I can write 2 to the power x equals to 1 plus root over 5 by 2. Now I will operate with logarithm on both sides having base 2. So from the property of logarithm, our x will get multiplied with log 2 base 2. Log 2 base 2 will be 1, so it is x times 1 equals to log 2 1 plus root over 5 over 2, and this implies x equals to log 2 1 plus root over 5 over 2. And that's it. This is our solution to the given problem.